The remainder theorem. If the polynomial f of x is divided by the linear x minus c here, right? Linear binomial of x minus c. X is to the first power, thus it's linear. Then the remainder is f of c. So this c is the same thing as this. Now when you have a minus sign here, that means change the sign of the c and put it here. That's why there's a minus here and there's no minus here, okay? So they have opposite signs from each other. All right, so if you're finding c from x minus c, if it's in the x plus or minus form, you change the sign. If it's in f of c form, or if it just says c equals, then you don't you change it to put it in x plus or minus, but you don't change it to use it. All right. So what this means is if I divide some polynomial, f of x, we're going to call it, by x minus c, then the remainder is f of c. That means if I plug c into whatever that f is, and I get out 10, well, if I do the division of polynomial divided by x minus c, the remainder is also 10. And this is a very nice result in math. So let's look at a couple of examples here, all right, and let's use synthetic division to do this and look at this, all right. So the first thing I want to do is determine what is c. So first of all, x cubed minus 2x squared minus 5x plus 6, okay, divided by x minus 3. Remember, divided by x minus c. So this is my f of x, and this is my x minus c. If that's the case, I need to know what is c, all right? Because f of c is going to go here, and then also on my synthetic division, if you recall, c, the same exact number, goes all the way over here on my little porch or balcony right here, okay? So let's go back and figure out what this is. So right here, what is c? If this is x minus c, what is c? Well, c is just going to be 3, right? It's the opposite of that number. That's what the minus sign means right here. Change the sign, okay? So then we're going to be finding f of 3, and that also means that 3 is on my porch of synthetic division. So what does it mean to be f of 3? Well, we already said this was f of x, right? Because it's divided by, f of x is divided by, that's this part right here, okay? So f of 3 means everywhere I have an x, I'm going to put a 3 in here, a 3 in here, and a 3 in here, right? So I'm going to have 3 to the third power minus 2, and then 3 squared minus 5 times 3 plus 6. So follow your order of operations. 3 to the third power is 27 minus 2. I cannot multiply this 2 and 3 together because the 3 is to a power. Exponents come before multiplication, PEMDAS, right? So this is going to be 9. 3 squared is 9. And then here, this is its own term. Negative 5 times 3 is negative 15, and then plus 6. So you do follow order of operations, but within each term, you can actually start them over again if you're separating them by pluses or minuses. And that can save you some steps sometimes. So 27, and then here, now I'm ready to multiply this. I don't do 27 minus 2. I do minus 2 times 9 is minus 18, or subtract 18, or negative 18. And then I'm going to go ahead and put those two terms together because those two terms are already simplified completely. So negative 15 and positive 6 is minus 9. And then 27 minus 18, put those together, you get 9 minus 9, and that gives you 0. So f of 3 equals 0. What the remainder theorem says is, I better get what right here for my remainder? I better get 0, okay? So let's just go through it and see. Let's just go through it and see what we get, okay? We've already said that the same number 3 here, this is c, goes on the porch here, right? So remember, in synthetic division, what you do is you have your 1, you have your negative 2, you have your negative 5, and you have your 6. The 1's here, the negative 2 is here, negative 5 and 6. It has to be in descending order, biggest power to lowest power, and every power, once you start, like if you start with x to the third, you've got to have a number for x squared, x, and the constant. Even if that number is 0, you have to have it for this or it will not work. It's got to be there, all right? So let's go ahead and take this and get rid of those lines there and extra numbers. So we've written our coefficients down. I'll set that up for you because synthetic division is prior knowledge here. So then 1 falls into the basement, right? You got on the second floor, it falls through the first floor into the basement. Then I start my process over and over again. I say 3 times the thing in the basement and write it right here. So 3 times 1 is 3. And then I say the word add. Now, you've been taught since you were 5 years old or before then that add, plus sign means add. No, a plus sign means don't change the sign and combine like terms. So I'm not changing the sign of my 3, and then I'm combining these terms. If you combine a positive and a negative, you do not add. You subtract and keep the sign of the larger number. That is the rule forever and always has been and always will be. Okay? So 3 minus 2 is 1. All right? And then we again start the process over. We say 3 times this number, and we write it right here. So 3 times 1 is what? 3. And then we add. We say the word add because we're not changing the sign of this 3. We are not changing that sign. That's why we use the word add. So then negative 5 and 3, if we put them together, again, subtract because they're different signs and take the sign of the larger. 5 minus 3 is 2. 5 is bigger than 3, so take the negative. So negative 2 there. Then we start the process over again. We take this 3 times this negative 2 and we write it right here. Okay? So 3 times negative 2 is negative 6, and then we add. My number's negative. I just don't change it. That's what add means. Don't change my negative 6 that I just wrote down. So what is 6 minus 6? 0. Bingo. Right? There it is. My remainder is 0. Bingo. But we knew this number here and this number here when we plug in f of 3, those are the same thing. Okay? That's a great result for math. All right? We're going to talk about the factor theorem next or in another video, and that's where this leads to, this remainder theorem. All right? So that's why this is such a great result here. So let's look at the next example here. 5x to the third plus 6x squared minus 3x plus 17, and then divided by x plus 2. So again, this is my x minus c. This is my f of x. Okay? So here, if that's the case, what is my c? My c here is the opposite of that, which is what? Negative 2. So then f of negative 2, and over here, negative 2 on the porch, okay, or the balcony, all right? So those two things are the same. You don't have to find both. I'm just showing you here that they're the same thing, okay? I'm just showing you here they're the same thing. So then f of negative 2, let's just go through and find it, even though if I was doing synthetic division to find the remainder, I wouldn't worry about this part. I'm just going to show that they're the same, not proving anything, just giving you an example of when it works. So here, this time, this is my f of x. So now I'm taking this negative 2 and plugging it in here, here, and here, right? So I have 5 and then negative 2 to the third. You've got to have parentheses here. You didn't have to have it around this 3 because it was positive and there was nothing in front of it. But there, this negative 2 must have parentheses around it. Otherwise, it's not right. It's not right if I do it, if you do it, if somebody else does it, your other teacher, whoever. It's not right, okay? So 5, negative 2 is in parentheses cubed. And then we have plus 6. And again, negative 2 is in parentheses because you're squaring it. You're squaring the 2 and the negative. That's why the parentheses are around it. That is immensely important. And then we have minus 3. And then again, negative 2 in parentheses times. You can use a dot. There's different ways to show that one. It's not being raised to a power. All right. And then plus 17. So here, order of operations, do negative 2 cubed first. So 5 and then a negative 2 times negative 2 times negative 2 is negative 8. It's important there you're cubing the negative sign. 3 negatives makes a positive, right? The first two make 3 negatives make a negative. The first two make a positive, and then times the third negative makes it negative again, okay? So 5 times negative 8 and then plus 6. What is negative 2 in parentheses squared? That is negative 2 times negative 2 is a positive 4. And then here, again, new term, I'm just going to go ahead and multiply those together and get what? Plus 6, right? 3 times 2 is 6, and a negative times a negative is a positive, and then tack on my plus 17. Here, 5 times negative 8 is negative 40, and then again, plus 6 times 4 is plus 24. It's a new term there, still in the multiplication phase here. And then I'm going to go ahead and combine those two terms. They're already simplified. 6 plus 17, and they're both positive, is 23, right? So however you do this, it doesn't matter. I'm going to put my two addings together just because that seems simpler to me here. So that's going to give me negative 40 and then plus 47. And if I put those together, they are different signs. So I'll subtract 47 minus 40 is 7 and keep the sign of the bigger. 47 is bigger than 40. Okay, so then 7 is that final answer there. So that means that when I go through synthetic division here, and when I get over here to my remainder, you don't have to box it off. That's just what I do. Okay, then that remainder better be what? That better be 7, or I goofed up, right? So let's go through this. The first thing we do in synthetic division, again, the 5 comes down, the 6, the negative 3, and the 17. It's in descending order. It goes 3, 2, 1, and then no power of x there, no x's. So that's in descending order, and every power is accounted for. So that's where I get the 5, the 6, the -3, and the 17. All right. So first thing we do is drop 5 into the basement. Then we do -2 times 5 and put it here. What is -2 times 5? That is -10. 6 minus 10 is -4, right? Again, we say the word add. We add 6 and -10. That just means don't change the sign and combine like terms. When you combine a +6 and a -10, you subtract, you keep the sign larger. Then again, we say -2 times -4 and write it right here. Negative times negative is positive. 2 times 4 is 8. And then we add. Don't change the 8. So -3 and 8 is actually 5. We are subtracting there because the signs are different. But we say the word add because we are not changing the sign of that. I can't stress that enough. Okay? -2 times 5 is what? -10, and we write it right there. So -10. And again, I say the word add, but I don't change the sign. 17 minus 10 is 7. Bingo, we got the same thing that we got when we plugged in -2 to our f of x, which we determined was this in this case. Okay? So that is the remainder theorem. Again, I didn't prove anything with these two examples. Rarely ever do you do both synthetic division and get a remainder and plug in the function f on the same problem. I'm just showing you here that they are the same. I did one that's 0 and one that's not. Okay, it can be a negative number, it can be something else. It's going to be the same thing every time because it just simply works. All right.